Throughout a long and productive life, Alwin B. Newton made major contributions to the science and art of commercial residential air conditioning and refrigeration. As both a fellow and a life member of the Society, his recollections form a vital part of the history of ASHRAE. He pioneered many concepts which were recognized in patents fundamental to today's refrigeration and air conditioning industry. This interview with Mr. Newton was conducted on June 26, 1985, and is herein transmitted the first contribution to the permanent oral history collection of the Society. Al, I know that you've been in the industry for a long time. When did you start? Who were you with, and basically what did you do?
I became interested in refrigeration and air conditioning when I was at Syracuse University, and that probably culminated about 1928 when I joined the student section there of ASH and VE, I believe it was. And I did a few research projects for one of the professors, A.R. Aitchison, at Syracuse. And also I found one project very interesting because one of the managers of a large department store wanted his house air conditioned. And it was too small a job for the big contractors and too big a job for the people who were doing refrigerators. So I took on the job. This was 27 or 8, I don't remember the exact date. And believe it or not, what we did was to put a 15-ton ammonia water chiller system in a depression, a cavity that we made under his driveway and covered with an iron grate so that if it ever leaked, it wasn't getting into the house. And the chilled water went into an air washer. That was my first air conditioning job.
Okay, so then after that, what was the first work you did after you graduated and joined a company?
Well, I went to General Electric Company in Lynn, Massachusetts after that. There we had an opportunity to choose some of the projects on which we worked. And Carrier funded a project on railway air conditioning with the concept of using a small centrifugal compressor to produce the liquid refrigerant, which was pumped between 8 cars in the train with individual units.
How did they manage to couple from car to car?
That was their big problem. The system never found anything except experimental use. It did work quite well experimentally, but it was one of the first exposures I had to something that was running about 44,000 RPM, and that was back in 1931. We thought that was high speed then.
What did you do after that?
Well, generally, I was taking courses at MIT then, and finally graduated from MIT with a master's degree. And there I did specialize in heating and ventilating and air conditioning.
That was a master's degree in engineering?
Yes, in engineering. I found myself, this may be of interest, I got married in August of 31, and when I went to MIT for full time, I was one of 5 married students, and the only one who didn't live on the campus. I lived in Lynn still.
What did you do after you got your degree?
After that, York Ice Machinery Corporation interviewed several of us at MIT. I was one who accepted. There were, I believe, 5 of us who went down to York at the same time. Interestingly enough, we were hired at $120 a month. And when the first paycheck came after early July, it didn't look like that. And the boss said, well, probably something wrong in accounting, just wait till the next one comes. So the next one didn't look that way either. So we finally got to one of the top dogs in the company. He said, oh, didn't you know we all took a 33% cut after you were hired? So we got along on $80 a month for a while. But I did get into drafting work. In fact, the Air Conditioning Refrigeration News recently carried an article about a 50-year-old job in Humble Oil, Houston, Texas. I designed the water chillers for that because I'd done heat transfer work at MIT. Nobody knew about heat transfer in Freon, so we used the basic principles to guess at it. Came out very, very well.
I believe that was when Freon was in its infancy. It was placed on the market in, was it 1931, I think?
I believe that was the first of the large 200-ton size, that is, Freon units, and that was expanded from there on. Those were reciprocating compressors. I think they were 14 by 16-inch, 8-cylinder compressors.
Your early work was in the refrigeration area?
Yes, although refrigeration for air conditioning, you see. Humber Oil was a big office building. Then we did also work for all the big buildings in Washington at that time. I did National Archives units and the U.S. Post Office initial designs, so forth and so on. From there, I went into the development department at York to develop new products.
And what were some of the products you were assigned to work with?
Mostly in the residential and small air conditioning field, because that was brand new. And of course, the opening up of Freon gave us an opportunity to put equipment where we never could before.
What year was it that you began to work on domestic air conditioning?
About 1933. And in fact, we built an experimental house, which is still existent in New York. I stopped by and saw the owners a little while back. They didn't know their equipment or their house was that old. It was built, I believe, in 1933. And I gave them a set of the plans for the original house. And then we did room air conditioners. I think York had the first room air conditioner that was actually marketed. De La Verne over in Philadelphia had the first one with hermetic compressors. There were units that sat in front of a window on the floor with a duct going through a slightly raised portion of the window to get condenser air.
What were some of the developmental problems that you ran into when you worked on window air conditioners?
Well, one of the first ones was the fact that any unit like this has to operate well over a very wide range of condensing temperatures. Outdoor air changes in temperature rapidly, and so does the load change in the building. But I may have to do air conditioning when it's 100 degrees outside, and I may have to do it when it's 60 degrees outside. So the condensing temperature varies. Refrigerant control became a problem. Condensate disposal became a problem. I think one of the first patents I ever got was on the method of getting rid of the condensate into the airstream. We had the basic patent on that.
Was that when you slung it up into the airstream using a condenser coil?
That's right, into the airstream and against the condenser, a coil. And also a method for getting the expansion valve to work well over a very wide range of temperatures without hurting the performance of the evaporator.
Did that unit use a thermostatic expansion valve?
A thermostatic expansion valve and an external heat exchanger to produce the superheat. I believe it's the first unit that ever did that. We have a patent on it, one of my early patents. I have about 215 patents.
So how were you able to overcome the problem with the expansion valve?
We worked with Alco, whose standard valve had a superheat differential of perhaps 4 or 5 degrees. In other words, it's a very sensitive valve. And if you depended upon that kind of a valve to control over that wide range, it became unstable in many cases, and you just open and close and open and close, flood back and starve the evaporator. So we added the external superheater, liquid suction gas, in such a way that any liquid carried over went against the wall that contained the liquid, so it would easily evaporate. And we changed the differential, if I remember rightly, to about 25 degrees, much greater, so that we could be stable over a wide range. Its performance at that time was so far ahead of others that came out a year or so later that it was amazing, and it was mainly because of better control, better refrigerant control.
So you had problems of disposing of the condensate, and you had the expansion device problem. What other things did you run into?
I'd say that those were the biggest problems. We had problems of maintaining good performance in the condenser as the airflow temperature range changed. But we did that by just crossover feeding, which became a fairly standard way in the industry. And that was the main thing. Of course, noise was a problem. We had to find ways of keeping everything quiet. Another chap by the name of Emil Neubauer and I worked together on a method of mounting so that we were flexible across the center of gravity of the motor compressor combination. and a little the way aircraft engines used to be mounted. And we made it very quiet.
Who comprised the team of engineers that really developed the unit? I mean, beside yourself.
I'd have to include Neubauer, for one, and Emil Neubauer, whom I just mentioned, he's no longer living. And perhaps, well, Charlie Neeson came with us by that time and had some ideas that we incorporated. He was not part of the team, but we worked with him. He came over from De La Verne, and he brought a man with him by the name of Reg Wild, who also worked with us. And those were the main people.
What were some of the other things you had to research and develop in those early days?
Well, we got into the general field of residential air conditioning. And to do that, York built, designed and built, I think, one of the very early fully air-conditioned homes. Certainly, probably the first one that was designed to be air-conditioned. And that home still exists in York, as I mentioned earlier. And we built a 5-ton air conditioner with an oil burner attached to it so that we could heat or cool. Developed an all-year automatic control system, which worked extremely well. I think sometimes better than what I see today. That was the next year. That would be 1934. And then right after that, a similar house, or not similar, but for the same purpose, was built over in Lancaster, Pennsylvania, by York and a real estate group over there. It's interesting in a way that we had to build this house. The whole house and the lot cost $16,000. Big house. So York thought that was a big investment, and they were going to rent it to somebody. First, they're going to have engineers live in it for a while, say 2 months at a time, and make notes on how the system worked and that kind of thing, record the results. Then this theater owner came along. He said, well, I want that house. I don't know what he finally paid for it, but something like $23,000 or $4,000. And the management couldn't see not getting that profit out of the house, so they sold it to him, with the idea that for a year we could take records. So for a year I used to get up most any time of night, go over there and see what was wrong or what was... He happened to sleep in the day and work at night, and he had all kinds of little things that happened. Most of them were no problem, but he thought they were. Gradually we got into the big water chillers for large buildings and the kinds of units you use in the room, you know, when you use them. The biggest thing, as far as I'm concerned, I saw that there was a great need for control, and I persuaded York to let me have a small group to investigate control and write a control manual. I wish I had a copy of it. I don't. But as a result of that, Honeywell got interested in me. And then I went to Honeywell in 1936 and was there for about 8 years. Had charge of their refrigeration controls division.
I've seen some of the older Honeywell refrigeration. Of course, they've been out of business now for a long time, but years ago they used to make low-pressure switches and things like that. You were probably the person who developed all of that.
A great deal of it. We developed them for the commercial refrigeration business, too. But you used to have walk-in boxes. Maybe you remember some in old butcher shops and so forth. The wooden ones or even metal ones. And the big problem there was keeping the coil free of frost when you had temperature levels around 36 to 40 degrees. So we developed a method of doing that, which was very successful. We did it by defrosting on every off cycle instead of waiting until the frost built up. Once in a while we lost a couple of degrees in temperature that way, but we kept the coil efficient and ready to cool all the time.
What medium did you use to defrost the coil?
Just the temperature of the air. It's high enough at 36 to 40 to do it if you don't start the cycle too soon. So we were the first people that developed the scheme of turning the unit off when the temperature in the butcher box got to be the control temperature, but keeping it off until the coil temperature was high enough to have defrosted every cycle.
Oh, okay. Now, in other words, when you switched the refrigeration system off, the evaporator fan would continue to run, and you'd have some mechanism to detect the coil temperature. And only until it rose to a certain temperature could the system cycle back on?
That's right. We call that a politron system. And it was the standard all over the industry for a while. In fact, it became the Navy standard out in the Pacific. We produced a very simple control for them, and they bought them by the thousands in those portable boxes.
Now, all of the earlier systems you worked on, the air conditioning systems, used thermostatic expansion valves as the refrigerant control. But then, later on, at some point, the industry switched to capillary tube control. Now, when did that take place?
I'd say the late 50s, that switch was fairly well along. And of course, it was done to save cost. It was done also with a considerable amount of degradation in the performance of the unit, except at one particular condition. We're already having problems with that again, because as we increase the efficiency of units, we're raising the evaporator temperature, so we don't have as much leeway for the capillary to make a mistake as we used to have. And I see units going back to expansion valves now because of that.
Over the years, in the various things you did, what did you think was your greatest engineering accomplishment?
Oh, it might not even be in the refrigeration field, but I think, well, lately, we've done a great deal in the electronics management of, well, speed control on compressors, efficient speed control on compressors. And I really believe this is going to be one of the most important things that's come down the pike. It allows you to adjust the speed to match the capacity, match the load. In doing this, you can reduce the temperature range over which you have to pump the heat, and thereby affect efficiency, improve it. We ran some systems like that, which were not electronic. Well, way back in the late 40s, there was experimentation between Air Temp and Philadelphia Electric, and we were able to get a seasonal COP of over 4.1 approximately, with a basic system that would have given us about 2.2 if it were just operated on and off. So the potential is there to do it. We may not ever reach quite that high a COP today, because we have gone to R22 instead of R12, and our valve losses and thermodynamic losses are probably a little bit greater. But we're talking about the old four-pole motors, R20, R12 type refrigerants, and we were there. So we ought to get back there one of these days.
Well, now, we were talking to Frank Faust the other day and said the same thing to him. It's important that we get the things that people like you remember, the personal things you did. I mean, after the fact, you can always go back and find patents and maybe find an article that somebody wrote. But the thing you can't get is some of the problems you faced, how you solve those problems, and those kinds of personal memories.
Well, I have about 180 out of the 220 patents. There's some missing, of course. So I'll see what I can do about that. I can certainly send you numbers.
Then with the numbers, we can always go and get copies of them.
You were asking about what I thought were good accomplishments, and there's one other thing I think I'll mention, because it still needs to have more attention. It was in 1928, I know, because I was at Syracuse University, when we were dealing with psychrometric charts and the air properties, humidity properties they show. We're dealing with primarily a carrier chart, and I won't go into detail, but it didn't relate everything in the locations that made properties easy to find. You read up to a director's line over to a scale, and you could never really draw cycles on it. So I created a different psychrometric chart. And it's been used since by Honeywell and by York and by Acme Industries as their standard psychrometric chart. I don't suppose it is now, because all that kind of thing goes on a computer. But recently, York asked me to develop for them some information on humidity control. And I found that old psychrometric chart one of the best ways to illustrate the path that the load causes temperature and humidity to take, the path that the operation of the equipment attempts to make it move, both move, and then what's the combined effect.
So with what you've developed, it's much easier to understand the process of conversion of heat and moisture.
Yeah, you can visualize it, whereas most people do not visualize what a computer spits out. They take it as gospel, whether it could be or not, and make a lot of mistakes, I find. So if you visualize it, you're more likely to be able.
Now, going back to your early days of work on air conditioning, who else was doing pioneering work in that area back in the late 20s and 30s?
Well, Carrier certainly was.
Especially with respect to air conditioning being applied to businesses and homes.
Well, they had small units too. And I'd say Frigidaire was one of the big ones. They're out of that business almost completely now, I guess. And the other GM division was Harrison Radiator. Gee, I don't know. I have to think about that a little, but those immediately come to mind, particularly General Electric with an expansion of their hermetic refrigerator concept. They also worked on hermetic compressors. And Westinghouse got into it probably by 1940, long in there.
Mr. Alwin Newton died on October 29, 1985, in York, Pennsylvania.